This segment we're going to talk about how we apply an entropy balance to a closed system. So remember, entropy is a property that is not conserved. It's not like energy and mass. It starts out like the conservation of equations, and that the change in entropy contained within the system is equal to the net amount of entropy transferred across the system boundary. But then you've got that third term out there, the amount of entropy produced within the system for that process. So the change in entropy, it's delta S. You could put this in terms of delta big S, or you can isolate mass and put m delta little s, where little s is in terms of kilojoules per kilogram K. And that's an intensive property. That's something that you can look up in your tables, or you can calculate if you've got an ideal gas. We've got a few equations for those. And then the net amount of entropy transferred into the system across the boundary. For a closed system, the only way that entropy can be transferred is with heat transfer. And then you've got the amount of entropy produced, which we use a sigma for that. And the units on this are going to be in kilojoules per Kelvin, or if you're in English units, it would be BTU per degree Rankine. So if you needed entropy produced per unit mass, you just divide through by mass, and that would give you kilojoules per kilogram K. Let's go back to that heat transfer term there. If the process is adiabatic, that integral becomes very easy to evaluate because your Q is 0, so that quantity right there is 0. The other case that we'll look at in this class is if the process is isothermal. So if it's isothermal, then the temperature everywhere in the system, including along that boundary where this integral is evaluated, it's just going to be that temperature. It's isothermal, so it's going to be the temperature during that process. An example with that would be a constant pressure phase change, but any isothermal process, this is the equation that you would use. So, all right, well, I hope that was helpful, and we'll work some problems the next time we see each other. Thank you for watching.